Now that we've talked about limiting reagents and quantitative features of chemical reactions, I think it's time that we explore a little bit more of the types of chemical reactions that you may encounter as we go through the subsequent chapters. And there's three that I'll point out right now and go through some of the features of. And those are combination reactions, decomposition reactions, and combustion reactions. So we'll start with combination reactions. It's fairly simple. It sounds, it's exactly as it sounds. We have two or more reactants, and they combine together to form a single product. And a few examples are shown here. We've got a generic example, but then, for example, solid carbon reacting with oxygen to form CO2, or the Haber-Bosch process we mentioned earlier, where we have nitrogen gas and hydrogen gas reacting together to form ammonia. Those are both examples of combination reactions. One that you may be more familiar with, though, is the burning of magnesium ribbon. So if you've ever seen magnesium ribbon lit before, it produces this brilliantly white flame. Well, what you're actually seeing here is solid magnesium combining with oxygen to then form this kind of white or off-white powdery substance, which is your magnesium oxide now. So this would be a classical example of a combination reaction. Decomposition reactions are almost the exact opposite. So we start with one single starting material, and that starting material breaks apart into two or more substances. Many compounds react this way when you heat them. That's a very common mode of decomposition, is normally thermal decomposition. And there are several examples here that are shown. Potassium chlorate here, decomposing to produce potassium chloride and oxygen gas. This is a reaction that's used if you've ever seen a chemical demonstration where people will light a gummy bear on fire. Often they use potassium chlorate. And there's a few other examples here, but one that's probably more familiar to you on a practical everyday level is the decomposition of sodium azide. So sodium azide is the component in your car's airbags, and with a small electrical spark, which is built in to be discharged in the event of an impact, that will cause the decomposition, rapid decomposition of sodium azide to produce just solid sodium and then nitrogen gas, which then inflates the airbag and prevents you from just smashing your head into your car's windshield. The last reaction that I'll mention right now, we will encounter more when we come to chapter 4, but this last one is combustion reactions. And combustion reactions have several details that go along with them. First, combustion reactions produce a flame. This is a common feature of a combustion reaction. So prototypical example here is a propane torch. And additionally, there are some other features that go along with combustion reactions. So first, on the reactant side of the equation, we must have oxygen. So combustion reactions require oxygen. That's the primary, it's the necessary reactant with whatever you're burning. And normally, most combustion reactions, the other reactant is a hydrocarbon of some kind. It may or may not contain oxygen, but it is composed primarily of carbon and hydrogen otherwise, hence the name hydrocarbon. On the product side, it is also very simple. Most combustion reactions produce just water and CO2, both in the gas form. And the last part is that it produces frequently a ginormous amount of heat as a form of energy. So let's go through this a little bit more in detail. So this example of propane burning, you can see we have the hydrocarbon, and oxygen as the reactants, and then CO2 and water as our products. So if we were asked to write the combustion reaction for some hydrocarbon, knowing this information, knowing these features of the reactants and the products can help us to predict the balanced chemical equation for a combustion reaction when we're only given the single starting material. So let's see how we go through this. First, we list the material that's going to burn, whatever that hydrocarbon is. We'll just take an example here of a long hydrocarbon C12H26. That's the starting material we've been given, and we were told, write the combustion reaction for this starting material. Well, the second thing I do is I add O2 on the starting material side, and I add CO2 and water on the product side. So O2 on the reactant side, CO2 and water on the product side, and I've left space there because nothing's balanced at this point. I've got 12 carbons on the left and only 1 on the right. Then the third step is now we simply balance the chemical equation. We go through, and as we did at the beginning of this chapter, we would start with the atom that appears in the element that appears in the least number of formulas, and then move on as we would go sequentially to balance a chemical equation. And we can do that here to provide a balanced combustion reaction. So these are 3 types of chemical reactions you will probably see: combination, decomposition, and combustion. And we will, in the next section, talk significantly more about combustion reactions and what we can gain from them in terms of chemical analysis.